This is paper 2, yeah, from May, June 2020, yeah. So I'll start. Okay, so here, okay, you can see this question, a sample of barium, okay, is heated in oxygen. So it's a metal, yeah. Metal, when it is heated in oxygen, okay, so I'll just put, okay, you are going to get a metal oxide directly. So the equation, yeah, is going to be barium plus oxygen, okay, it's going to give you barium oxide. And I have already balanced that for you. Yeah, but what you are going to see is, okay, whenever barium metal, yeah, when it is burned, yeah, when it is burning, the flame, okay, it's very important to remember, it will give you a green flame. Yeah, so something that you need to take note. And that is going to be one of the observation, okay. And another observation is going to be barium oxide, yeah, it's going to be a white solid. So when they ask you, okay, describe two observations for this reaction, okay, so you can actually just write, okay, the one of the observation is going to be a green flame, okay, is seen. And second, okay, is going to be the white solid, okay, is being formed. So you need to tell, yeah, the green flame is actually basically from barium. Okay, the white solid, okay, is actually coming from the green flame is more like barium 2 plus. Yeah, you can check. Okay, and the white solid is going to be the barium oxide itself. Yeah, so these are the two observations. Okay, and then when they ask you to write an equation for the reaction and include state symbols, I already put the equation, and just need to write this again. Okay, and then writing the state is quite simple, yeah, because this is going to be metal, so solid, yeah, and this is going to be gas, and this is a white solid, so definitely it's going to be solid. So you need to just write like that. Now, the second question over here is calcium carbonate, okay, can be converted into calcium hydroxide into in a two-step process. Okay, so I write down calcium carbonate, and then calcium oxide, and then calcium hydroxide. I think this one, okay, the first moment you see this calcium carbonate to calcium oxide, I think there is only one reaction, yeah, where you can actually decompose. Okay, when you have calcium carbonate, it will decompose to calcium oxide plus carbon dioxide. Okay, so this is what we call as thermal decomposition. Okay, so thermal decomposition. And how do you change calcium oxide to become calcium hydroxide? You just simply need to add water. So add water where? Okay, you add calcium oxide, you plus with water, they are going to give you calcium hydroxide. Okay, these are the two steps. Okay, but you need to describe, okay, how it is going to be the two-step process is carried out to convert the calcium carbonate into calcium hydroxide, include relevant equation. So you can actually write down like step 1. Okay, step 1, it is going to you heat because it's thermal decomposition. Yeah, so heat calcium carbonate. Okay, heat calcium carbonate. Okay, then the equation is going to be calcium carbonate. It will give you calcium oxide plus carbon dioxide. And then the step number 2, okay, once you heat, okay, you add water to calcium oxide. Okay, calcium oxide. So the equation is calcium oxide plus water. Okay, it will give you calcium hydroxide. Okay, and then check whether it's balanced or not. Okay, it's already balanced. Okay, so you can just put it like this. Okay, so I will also, while I'm doing this, I will also look at the answer key. Okay, so everything is correct. So the answer key is just telling about one, you must heat. Okay, so they give you mark for heat. Okay, add water, and then the equations. Okay, heat, add water, and then the equations that will give you 3 marks. Okay, which is in this case we are getting the 3 marks. Yeah. Now the following step, name the type of reaction, okay, occurring when calcium carbonate is converted into calcium oxide. Yeah. So this one, okay, we already know is a decomposition. Okay, but you need to be very specific. Okay, it's going to be thermal decomposition. Yeah. So the answer here is going to be thermal decomposition. And then this one, okay, you should one common use, okay. State one common use for both calcium carbonate and calcium hydroxide. So calcium carbonate and calcium hydroxide, okay, generally it's used to increase the pH of the soil. Yeah, so because if you put calcium carbonate, okay, into calcium carbonate, okay, you put the calcium hydroxide, both of them, yeah, both of them, they are going to be used, okay, for increasing pH of the soil. Okay, so I just put it over here. And James, we just started, yeah, so it's also being recorded, yeah, so the plan is to complete the paper, okay, but if you need to leave, then you can leave also, no problem, James, yeah. So we will just continue. I already WhatsApp you the paper, yeah. Now, so the next question over here, okay, you have this gallium, yeah. So gallium is a silver gray solid, okay, and then they mentioned that aluminium and gallium, okay, share many similar chemical property. Now, when this one you are given with the data booklet, okay, so of course you need to always check whenever you're dealing with this kind of question. You always check, okay, if they say similar chemical properties, will be most likely they are in the same group. Yeah, so if you look in your data booklet also, you will find that aluminium, okay, aluminium is at the top, gallium is at the bottom, so it's actually still from the in the same group. Yeah, so it is important, okay, it is important because all the reactions that aluminium will undergo, okay, the gallium will also undergo. So here if you look at a constructing equation for the reaction of gallium, okay, when heated in oxygen to form gallium oxide, basically if you have aluminium with oxygen, they are going to give you aluminium oxide. Okay, so when I balance this equation, yeah, of course I put 2 over there. So this is 4, okay, so oxygen is going to be 6, so I put 3 over there. Yeah, so this one you can you know how to balance this. Yeah, but the same thing, okay, when it comes to gallium, they will follow, even though we didn't learn, okay, they will follow the same thing. Gallium, okay, you can do for the aluminium, and you just replace the aluminium with gallium also, fine. They will follow the same thing. Okay, this is going to be the equation. So construct an equation. So this is the equation for gallium, okay, plus 3 oxygen to give you gallium oxide. Okay, Ta2O3. So this is solid, this is gas, and this is also solid. Okay, deduce the oxidation number. Yeah, the answer is +3, but I'll show you how you can actually get this number. Okay, this one is going to be Ga2O3. So I just want Ga. Okay, so I can put it as X. Okay, put it as X. So 2 times X. Okay, you put 2X plus oxygen. Oxygen is always -2. So 3 times -2 equals to the overall is a neutral molecule. If it is a neutral molecule, equals to 0. Okay, and then you just need to find what is X. Okay, this is -6. You bring to the right, it's going to be +6. X equals to 6 divided by 2 is 3. Okay, but don't simply just put 3. Okay, it is important to put it as +3. And don't put 3 plus, yeah, that is for ion, yeah. So this is +3. Now complete the table, okay, by predicting the formula of each gallium containing product. Okay, so here they react, okay, gallium oxide with ACl, hot ACl, and then they react with hot concentrated sodium hydroxide. Okay, maybe this one looks a bit difficult, but if you use the aluminium, okay, as your example, okay, which is found in your textbook also, okay, then it will not be that difficult. You see, when you use aluminium, the equation should be like this. Okay, aluminium, okay, if you want me to rewrite this again, can, yeah, you see aluminium oxide, okay, aluminium oxide, when they react with any acid, so I'll write down the one we have it in the textbook, yeah. So in the textbook, they have written aluminium oxide, okay, can react with H2SO4, okay, they can give you aluminium sulfate. Now, aluminium sulfate Al3 plus, SO4 2 minus, this one times by 3, This one times by 2. So Al2SO43. Okay. So this one and this one done. Okay. Left with what? Water. Okay. So plus water. So you just left with balancing the equation. Okay. So you can see that aluminium is going to be 2. Sulfate is going to be 3. So if I put 3 over there, okay, and then I can, if I try to balance the oxygen is 3, I put 3. Hydrogen now becomes 6. Here left and right is 6, so it's balanced. Yeah, this is given in the textbook. Okay, given in the textbook. But now, okay, if let's say I want to apply the thing in the textbook, but now it's reacting with hot HCl. So if aluminium oxide, okay, when they react with HCl, same. Okay, HCl, they will give you aluminium is Al3 plus. Okay, so AlCl3, Cl minus. Okay, Al3 plus, Cl minus times 3. Okay, and then same plus water. And you balance this up, okay? So there's 2, so I put 2 there. And then here, okay, you have 6. So I just need to put 6 here. So here 6 hydrogen, so it means I need to put 3 there. It's done, yeah? But do remember, this is going to be for aluminium. You want to write for gallium, okay? It's the same, okay? You just need to change this, okay, into gallium. You just need to change this into gallium, okay? Which is, if I rewrite this, okay, it's going to be Ga, okay, 2O3 plus 6HCl, 2GaCl3 plus 3H2O. But they didn't ask us to write the equation. Yeah, so I'm just teaching you about the equation, okay? But they didn't ask us about the equation. They want the formula of the gallium-containing product. So what is the answer? This one. GaCl3 is the answer that they want. Okay, that is the answer that they want. And then the another one is going to be same gallium oxide with hot concentrated NaOH. Okay, so that is going to be, if you look at your book, okay, this is the equation that is given, okay, which is the aluminium oxide will react with sodium hydroxide. But the important thing to remember over here, the water must be there. Okay, you must add the water. And then you have this, yeah. So if you want me to rewrite this again, so basically just for aluminium. So aluminium oxide plus sodium hydroxide, okay, plus water, it is going to give you Na, okay, NaAlOH4. Okay, and then aluminium, there's 2 here. Okay, so it's better to put 2 there. Okay, 2 Na, so definitely there will be 2 here. And then you see whether the hydrogen is balanced or not. Okay, there's 2 hydrogen here. You have 8 hydrogen here. Okay, so 2 hydrogen go there, so you need 3 times 2, 6. Okay, this is how you balance. Yeah, but now, okay, you can write, okay, based on gallium. Okay, if you write based on gallium, you just need to change this into gallium. You just need to change this into gallium. That's it. Okay, if you do that, okay, the equation that you will get is going to be, if they ask you to write the equation, but in this case they didn't, yeah, so but I'll still write, okay, plus 2 NaOH plus 3H2O, they will give you 2 GaAlOH. Okay. So what is the formula of the gallium-containing product that you will have? GaAlOH4. This is very, very important. Okay, but in this sense, what we are learning over here, okay, if you look over here, this is aluminium oxide or gallium oxide. Okay, they are reacting with both acid and base. Okay, so we call, okay, group 3 oxides as Poiven, okay, there is a term that we use. Can you remember? Starts with A. What can you refer? Aluminium oxide and gallium oxide. James? Start with start with A, finish ends with C.
Amphoteric, something like that.
Yeah. So this is amphoteric. Okay, amphoteric, okay, because they can react with both acid and base. Okay, so the oxide, okay, of aluminium or group 3 oxide, they are amphoteric. Okay, so you can see that they can react with acid, they can also react with the base. So this one is found in periodicity chapter, yeah, in your textbook. Okay, I will move on. So here, okay, question number 2 is simple question. What is meant by relative isotopic mass? Okay, when you refer to relative isotopic mass, you just need to start from here, mass of isotope. Yeah, so you write down, it's the mass of isotope. So where do you compare? Okay, when you're comparing, you are comparing to 1 over 12. Okay, so you can just write down compared to, okay, compared to 1 over 12 mass of one atom of carbon 12. Okay, so that is going to be, even they say what is going to be relative atomic mass, then the mass of atom compared to 1 over 12 mass of one atom of carbon 12. Carbon 12 means it's the isotope also. Yeah, so the isotope that we use is the carbon 12. Okay, this will give you the 2 marks. Now, for this one, okay, you need, okay, I think someone is here. So maybe there is going to be another class or what. When are you going to use the room? Okay, she left. Okay, so now, okay, so you see here, okay, the sample of copper contains 2 isotopes. Yeah, so these 2 isotopes are copper 63 and copper 65. Yeah, so the relative atomic mass is given. Yeah, so when you want to use, when you want to solve this kind of question, I already did it before. Yeah, but I can do it again. You see, when you have 63.55, okay, how do you get it? Okay, so normally we take out of percentage, okay, the abundance. Okay, so let's say I'm taking the abundance as X. Okay, so let's say, for example, like 30% and 70%. So let's say X is going to be 30. Okay, so how do you get the remaining? Is going to be 100 minus 30, something like that. Okay, so now I'm good. I do not know what is the abundance. Okay, so the abundance, I'm just taking it as X. So let's say X, okay, divide by 100. Okay, X divide by 100. And then I'm going to times with 63. Okay, this one. And then plus, okay, that's a formula. Yeah, a plus the remaining. Okay, what is the remaining abundance? So I'm using to the base of 100. So 100 minus X. Okay, so X can be any number. Yeah, can be 30. Yeah, can be 70. That is what we want to find. Yeah, so 100 minus X. Okay, divide by 100. Okay, and then this is 65. So what we need to do is to find X. Okay, and then that X will be in percentage form. Yeah, so I have done this for you. Okay, the same you just do. Okay, you can find out the X is going to be 72.5. Okay, so it means that, okay, I know the X, okay, this is 72.5, okay, which is going to be 72.5%, okay, is 63, copper 63. Yeah, so that is going to be, I can just say 72.5%. So what is the percentage of abundance of 65? So 100 minus X. So 100 minus 72.5. That is going to be, you will get 27.5, if I'm not mistaken. Yeah, 27.5. Okay, so 27.5 percent. Okay, that is how you calculate. Can James?
Sorry, sir. Just now my Wi-Fi incredibly laggy. So basically, the summary of this thing get the 63.55 like that, and then what the times, can explain the X part
Can,
again?
can. You see, okay, when you have the chlorine, right? Okay, chlorine, they are built from two types of isotope. Okay, if you can remember the chlorine 35 and then chlorine 37. Yeah. So the actual value that you get from your data booklet is going to be 35.45 or 35.5. Let's actually take 35.5. So if I want to find out how many percentage, okay, is this and how many percentage is this, okay, using these values, yeah. So I can find out, okay. How can you find out? Okay, you just take it as, okay, X, okay, just put it as X, okay. And if I'm going to use percentage, then this will be maybe 100 minus X. Okay, so X and 100 minus X. So if it is going to be 30, then the other one will be 70, something like that. So I need to find. So how do I solve this? Okay, I just need to use 35.5 equals to X, okay, divide by 100 times 35, okay, plus 100 minus X divide by 100, okay, you times with 37, okay. And then you can find the X value. Okay, you can find the X value. Similar to that, okay, I don't want to waste the time over here. You will be able to find the X value. Maybe roughly you will get X is going to be 70. Okay, 70, and then
Yeah, and then just put it back to the other one to find the other one.
yeah. So if you go to the other one, it's still the same same concept. Yes, still the same concept. So I just use the same concept. You just do, okay, just do find the X. That's it. Okay, and then you get 72.5. So the other one, you just need to 100 minus X. So you can find out for that 65. Okay, quite simple. Okay. Now, so name the type of bonding within a sample, okay, of a solid copper. Okay, copper is metal. Okay, so the type of bonding is going to be metallic bonding. Okay, metallic bonding. Draw a label diagram to show the bonding within a sample of solid copper. Okay, first, if you want to draw, okay, a sample of solid, okay, first you must draw a regular arrangement of solid copper. Yeah, so a regular arrangement of solid copper, basically they are going to be arranged side by side, okay, in a regular arrangement. Okay, so I'll just put it like this, okay, regular arrangement. Okay, even here, okay, okay, I'm just giving some space, okay, but again, if you want to put it nearer a bit, it's also fine, okay, but I leave a space over there because I just want to show the electron, yeah. Solid copper, okay, copper generally they form Cu2 plus, okay, but of course they can form Cu plus and so on, but I just want to show the electrons. So each atom of copper will have two electrons surrounding that atom. So I'm just going to use the negative over there, negative 2. So negative 2 electrons, 2 electrons, 2 electrons, 2 electrons, 2 electrons. So everything I just put 2 electrons. You can see something like this. So you label, okay, you label, okay, which is going to be, this is going to be the copper ion or the metal ion, okay, copper or the metal ion. So in this is copper, so copper ion, okay, copper ion. And here, we just need to label, this is a special type of electron, delocalized electron. You must label delocalized electron. Okay, if you don't label that, okay, you will not get them. Okay, so you need to show that. Okay, don't go and draw something else. Okay, I think this one you can try to follow. Okay, but again, if it is ion, okay, it's always better to show them. Okay, they are ion by showing them plus. And that's why this is how you draw. Okay, of course they shouldn't be drawn in this particular concept. If you want to change it, like, okay, I just want it like this, okay, like this, okay, no need to follow 100% like how I draw. Okay, as long you show electrons surrounding them, it's okay. Yeah. The next one, okay, electronic configuration of copper atom. Yeah. So for this question, okay, it's always better if you know how to read the electronic configuration using your data booklet, using your periodic table. Yeah. So roughly, I took a certain portion of the periodic table over here. Okay, you see lithium, okay, lithium, beryllium, sodium, magnesium. Okay, if you look at your periodic table, you will see all this. Okay, and then scandium, all these transition metals. Okay, and then we are looking for copper. And towards the end, you can see here argon. Okay, towards after magnesium, after copper, then on top is going to be argon. Okay, now how do I use this? Okay, do remember, okay, the hydrogen and helium. Hydrogen is 1s1, helium is 1s2. Okay, hydrogen, okay, helium. Then lithium will be 1s1, 1s2, 2s1. Okay, so it means here you can start with 2s. Okay, that's why if you want to use this method, this one is called, okay, the S block. This one is called the D block. This is the P block. Okay, if you remember. Yeah. So here it is going to be, this is called 2s. This is going to be called 3s. This is 4s. So when I look over here, okay, when I want to get something from here, copper, it is better to look at the short form is at argon, and then you come over here is 4, okay, 4s2, 1 and 2. The moment you come over here, then 4, this is automatically 3D. Last time I told you how to read, yeah? So 4s, then it starts with 3D. So you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 3D 9. Okay, but do remember, copper is a special situation, okay, because, okay, it is better to have a complete orbital, okay, to form 3D pen. Okay, so what happened? One of the electron over here, okay, because the s and d orbital, the energy level is almost the same. So they can actually move from 4s to 3D. So it's supposed to be AR 4s1 3d10. Okay, but this is short form. Okay, you do not write using short form, and again they already put 1s2. So what you need to do, okay, is going to be to write for argon. Okay, argon is what? Yeah, argon is over here. Okay, so argon. Okay, if you look at argon, okay, maybe I'll just continue. Yeah, so argon is going to be 1s2, 2s2, 2p6. Okay, this is going to be 10. Okay, 10 is neon. Yeah, if you remember. Okay, neon is on top of argon. Okay, if you continue further, okay, so 3s2, 3p6. Okay, and then if you continue further, okay, we don't write down 3D, but again, you see here, 10, this is going to be 8, now it's 18. So this is the one that is going to be argon. So argon is that. Okay, because argon is going to be 18. So you write down 4s1, 3d10. So the reason also, you do remember 4s is filled first, okay, then only you fill up D, yeah. But all this doesn't matter if you know how to use the data booklet, the periodic table, to find out this answer, yeah. So this is how you get the answer for this, okay. So I hope you learn about how to use the periodic table properly, yeah. So that's why it's called S block, D block, and P block, yeah. So coming back over here, okay, they will start again. I think if it is 4s, so this one will be 4p, okay, as well, same, yeah. But this one you will, okay, if you want to study on your own or you want to ask more questions on this, you can ask me some other time, yeah. Now, the next question over here, okay, a student is provided with a sample of hydrated copper 2 sulfate, okay, and asked to determine the value of X. Okay. The student dissolved the sample of hydrated copper 2 sulfate in water and adds it to an excess of potassium iodide to make a total volume of 250 cm cube solution. So they add, okay, this is going to be solid, okay, so they add to an excess amount, okay, so whatever it is, okay, the total volume, okay, whatever that you get, the total volume is 250 cm cube solution. And the amount of iodine produced during this reaction, okay, is found, okay, by titrating a sample of this solution with sodium thiosulfate solution. Okay, so do remember the iodine is inside 250 cm cube solution. That is very important. Okay, now you only take, okay, you see I will draw directly from here. Okay, you will take 25 cm cube of this sample only. Okay, so you only take a certain portion. Later, you need to change it to 250, okay, when you calculate the overall. Okay, now you take 25 cm cube of the iodine containing solution. Yeah, so now this is 25 cm cube. Okay, you titrate with this. Okay, so this one is 20 cm cube. Okay, and then 0.1 mole per dm cube. So it means I know what is going to be the number of moles. Okay, I know what is the number of moles of this if I can count. Okay, and I can identify, okay, what is going to be the number of moles of this, and I can also calculate, yeah, a lot of things from that. So here, when they say calculate the amount of moles of copper 2 sulfate present in the original sample, okay, of the hydrated copper 2 sulfate, okay, so I want to calculate, it means they didn't give us some chance how to they say straight away calculate, yeah, calculate the amount in mole copper 2 sulfate, yeah, so I need to calculate the copper 2 sulfate directly. Okay, so how do I do that? Okay, so to get this done, okay, first, okay, you need to find out what is the number of moles. Okay, let me see. Okay, here, okay, I think we still need to do everything, okay, within these 2 marks, yeah. So I find out what is the number of moles of S2O3 2 minus, okay, that's going to be 20 times 0.1 divided by 1000. So this one is 2 times 10 negative 3 mole. Okay, this is going to be the number of moles of S2O3. Now, if you have that number of moles of this is 2 moles, okay? So it is going to react with 1 mole, okay? So in order to get this given, what do I need to do? Number of moles of I2. Divide by 2, yeah? So I will get 1 times 10 negative 3 mole. Okay, so do remember the number of moles of I2 that you found out is only in 25 cm cube. Okay, so you need to change it to 250. Okay, so what I need to do, okay, it means just take it as one example. This one, if I divide into 10, okay, if I divide into 10, okay, randomly I put, if it is divided by 10, the one portion of it, okay, one small portion of it contains, okay, this amount, which is going to be 1 times 10 to the power of negative 3. I am just looking for the entire portion of it. Okay, so how to get it done? You need to change it to 250. So how many 25 cm cube are there? So must be 10. So I times that with 10. Okay, I need to times by 10. So it means the number of moles of I2, okay, in 250 cm cube solution, okay, is going to be 1 times 10 negative 3 times 10, which is going to be 1 times 10 negative 2 moles. So now I know that this is 1 times 10 negative 2. Okay, I know this. But what they want, okay, is the number of moles of copper 2 sulfate, original. You see, 1 mole, 2 moles. Okay, so James, what do you need to do? If this is 1 times 10 to the power of negative 2, if I want to find out this, what is that value?
Times 2.
Yes. So this one, when you times by 2, you will get, okay, 1 times 10 to the power negative 2 times 2 is going to be 2 times 10 to the power of negative 2. Okay. So I'll just put number of moles, okay, of the copper sulfate, okay, in the original one, yeah, 250 cm cube, okay, is 2 times 10 negative 2 mole. Okay, that is the answer. Okay, once you get that, okay, we will continue further. Yeah. So here, okay, a total of, okay, now you have all these values now. Okay, then only you can continue working. A total of 7.98 gram of copper sulfate, okay, is present in 10.68 gram of copper sulfate dot X H2O. Yeah, what does it mean? If I have copper sulfate dot X H2O, I can divide them. This is copper sulfate, okay, and the remaining is water. Okay, if I separate, okay, and if I want to find out the mass of copper sulfate alone, okay, you see copper sulfate alone, 7.98 gram. Okay, so can you find out, okay, what is going to be the mass of water over here, James? How to find out the mass of water?
Not sure.
You only have copper sulfate and water in CuSO4 H2O. So if copper sulfate alone, just alone 7.98, how do you find the mass of water?
Water 2.7.
So how do you get that?
Minus.
Yeah, you minus. Yeah, 10.68, you minus 7.98, you will get, again, can you repeat again?
2.7.
Okay, so I'll write down 2.7 gram. Okay, so here, okay, you still need to find, okay, you still need to find in moles, okay, but here you see the amount of copper sulfate, okay, copper sulfate is 7.98 gram, okay, amount of water is 2.7 gram. I still need to find the number of moles, okay, so let's divide, okay, copper sulfate is 159.6, water, okay, water is going to be 2 times 1 plus 16. Yeah, so total is going to be 18. Yeah, the MR of water. So it's 18. So calculate what is going to be the number of moles. Okay, can you tell me the number of moles?
Have for the 2.7 divided by 18, 0.15, and then the other one divided by get 0.05.
Okay, okay, you will get this. Okay, this is number of moles. Okay, and I want to find out, okay, what is going to be the value of X. Okay, how to do that? Okay, remember the way that we use the empirical formula. Yeah, so if you divide, okay, you see here, this one you are getting 0.05. Okay, this one, okay, you are getting 0.15. Okay, when you use the empirical formula method, yeah,
X3, right? X3, because that's 0.15 divided by
yes. So we use the same method as empirical formula. Remember the simplest ratio. So how do you get simplest ratio? You divide with the smallest value. So you divide by 0.05, divide by 0.05, you will get 1 and 3. Okay. So the simplest ratio is 1 to 3. Yeah. So if you have 1 to 3, there is no 3. This is 1. Okay. Automatically 1. So must have 3 moles of water. So X is automatically 3. Okay. This is 3. Can you understand this? Okay. So that is going to be, you get the marks. Okay. Quite easy. Yeah. Now, the next question, okay, sucrose is a white crystalline solid, yeah, and then this is sucrose, okay, sucrose, and then in this reaction Z, sucrose reacts with water in the presence of catalyst, so they are reacting with water, okay, with the presence of catalyst, okay, aqueous hydrochloric acid. It means the catalyst is aqueous hydrochloric acid to form glucose and fructose. Now, you see here, it's going to be 12 carbon atoms. You see, this is 1, 2, 3, 4, 5, 6. So it means 6 carbon atoms, 6 carbon atoms. It means they are separating. They are making from something that is complex to become something that is simple. Yeah. So there are only few steps. Yeah. Like, for example, last time we learned about ester, for example. Ester, you can break down, yeah, into carboxylic acid and alcohol. That breakdown, okay, is called what given? What is the name of that mechanism? Breaking down of ester.
I forgot, sir.
James, breaking down of ester is the same concept. Breaking down, normally breaking down is what? Lysis. Okay, breaking down means lysis. Using water. Okay,
electrolysis.
Yes, that's why, okay, even not only applying to here, okay, even though it applies for ester, okay, ester hydrolysis, okay, when it's going to be applied like for something else, like maybe protein, yeah, we haven't learned yet, but if it is protein, you can also go through hydrolysis as well. So here, okay, you see it's going to be this reaction, suggest a name, okay, for this reaction. So the name for this reaction is going to be hydrolysis. To be exact, it's called acid hydrolysis. Okay, but it's okay. Okay, it's going to be a hydrolysis. Okay. Now, if no catalyst is added in reaction Z, okay, the reaction is very slow. Yeah? Label the Boltzmann's distribution, okay, to show the effect of adding catalyst to the sample of sucrose and water molecules at constant temperature. Now, at constant temperature, do you think, okay, do you think the shape of the graph going to change?
Constant, no.
No, yeah, always remember, the shape of the graph is going to change whenever you're talking about temperature, yeah? So Maxwell-Boltzmann's curve, like for example, if you're talking about lower temperature, okay, lower temperature will be slightly, if I draw, okay, it's going to be maybe like this. The graph will look like this, okay. As the temperature increases, okay, as the temperature increases, okay, the graph, okay, will be moving to the right, okay, moving to the right, and it will become, the peak will become slightly shorter, okay. So it means this one is going to be maybe 40 degrees. This is going to be maybe 50 degrees, okay. I want you to remember that, okay. But this one, okay, when they say adding catalyst, okay, doesn't change the shape of the graph. Yeah. So catalysts don't change the energy. Yeah. It doesn't change the energy. But what they will do, they provide an alternative pathway with lower activation energy. So in this case, the energy, let's say without, okay, without catalyst, this is what we call activation energy, the minimum energy required, okay, for the reaction to happen. Yeah, enough energy for the reaction to happen. So here, okay, if I say here, this is going to be number of particles, okay, number of sucrose molecule, okay, having more than EA, okay, without catalyst. Okay, you can see the area under the graph is going to tell us the number of sucrose molecule. So now what is going to happen when you add catalyst, the catalyst is going to decrease the activation energy. It means now the activation energy is here. So maybe the activation energy now is going to be here. Okay, so you need to label activation energy with catalyst. And what this will do, okay, it will make, okay, the number of sucrose molecule having the energy greater, okay, you can see here. So this one, okay, is going to be number of sucrose molecules having energy greater than the new EA. Okay, so you will have more particles having enough energy, they will react more. Okay, so that's why the rate of reaction will be more. Yeah, so that's the thing. So explain your label diagram and so on. Yeah, you can just explain. Yeah, like what I already label and also explain over there. So you just need to put it in words only. Yeah, Ken, James. Okay, so if you continue, so both fructose, and glucose contain chiral center. Okay, so they have chiral center. So explain what is meant by chiral center. So even what is meant by chiral center even?
The carbon atom that's connected to 4 different R group.
Okay, correct. So chiral center is going to be an atom, okay, or you mentioned in this case carbon. Yeah, generally we use carbon. Okay, so just say carbon atom attached to 4 what? 4 even just now you mentioned what?
R group.
Okay, for R group rather than saying R group, because the R group can be also Cl, can be also Br. Okay, rather than saying R group, okay, you just need to mention 4 different, okay, 4 different groups. Okay, 4 different groups. So it is also not only limited to R group. Okay, it can be Cl, it can be anything, but as long there must be 4 different groups. Okay, that's the meaning of chiral center. Now, on the diagram on the fructose molecule, label all the chiral center with this asterisk. So here, okay, if I want to label, okay, do remember they want to label chiral center, it means carbon, okay? Don't go and label oxygen over there. Don't go and label hydrogen, because hydrogen can only form 1 bond. Oxygen can form only 2 bonds. Okay, I want 4. Okay, I want 4. So I need to, if let's say I want to select over here, don't, no, okay, no, okay. Here you see 2 same groups, no. So here, okay, you see HOH, this is a different group. This is going to be different, so this is going to be, okay. I'll erase the part over there, okay. So you see this is 1, okay. And then here, 1H, okay, you can see this entire thing is different. This entire thing is different. This entire thing is different. Yeah. So 4 groups. Okay. So if this is also. And if you look at here, okay, here is going to be HOH. And then you have this, okay, and then this, they are different, okay. Automatically, this is going to be another one. And you can see here, okay, this one, no. Okay, you see same 3 groups only. Okay, you need to have 4 groups, so cannot. You see 2H group, cannot. O and H cannot. So total, okay, how many chiral center over there? There are total 3. Okay, total 3. Now determine the empirical formula for fructose. Okay, fructose, okay, they already gave you fructose. Okay, so you see you just need to find out what is the number of carbon. So you see 1, okay, see whether they have given anything. Okay, they didn't give you any clue, so you need to count. Yeah, 1, 2, 3, 4, 5, 6. Okay, C6. How many hydrogen? Okay, you count. 1, okay, 1, and then 2, okay, 3. Yeah, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many oxygen? 1, 2, 3, 4, 5, 6. Okay, this is going to be your molecular formula. So empirical formula, okay, you need to divide by 6. So it's going to be CH6O. Okay, so 6. okay, divided by 6, CH2O. So it's 6, 12, and 6. So 1, 2, 1. So C1, okay, H2O1. So it's CH2O. Okay. So here, okay, if you want to write down, the empirical formula CH2O. Now, explain what is meant by the term enthalpy change of combustion. Okay. Enthalpy change of combustion is going to be, okay, if you want to write down, yes, you always start with enthalpy. So what is enthalpy change? So it's going to be enthalpy change, okay, or to be in simple form is heat change, okay, but it's okay. You can actually use enthalpy change, it's okay. Enthalpy change, okay, when, okay, this is combustion, when 1 mole of a substance, okay, is completely burned with excess oxygen. Okay, so you can actually just react, burn, combust. You can use all this. Okay, so when 1 mole of substance, I'll just use reacts. It's easier. Yeah, when 1 mole of a substance reacts with excess oxygen. Okay, react with excess oxygen. Okay, okay, they didn't say standard condition, so no need to put under standard condition. If they say standard condition, then you need to put. In this case, no need. Yeah, but if you still want to put, also no harm. Yeah. So enthalpy change when 1 mole of substance reacts with excess oxygen. You will lose mark if you don't mention excess. Okay, you must mention excess. Okay, write the equation for the complete combustion of sucrose. When you want to write the equation, okay, you use the molecular formula. Yeah, so this is C6H12O6, okay, plus oxygen, okay, it will give you carbon dioxide and water. So what you need to do is just to balance the equation. So 6 carbon, I put 6 carbon. Hydrogen is going to be 12, so I put 6, okay. So how many oxygen? 6 oxygen and 12 oxygen, 18 oxygen. So 6 is over here, so I must have 12 oxygen, so I put 6. That. Okay. So this one you just need to put, okay. Okay, my connection. Okay, let me see. Okay, I got disconnected for a while. Okay, just give me a moment. Okay, just give me a moment. Okay, the connection is unstable, okay, but we can, as long as you can hear me, okay, it's okay, we'll start to go on. Okay, so here you see, okay, that the next question over here is, they are looking for the enthalpy change of reaction, okay, and then they give you combustion data. So they give you the combustion of sucrose, combustion of glucose, combustion of fructose, and so on. Now, use the data in the table to calculate, okay, the enthalpy change of the reaction occurring when sucrose reacts with water. Okay, and you should draw a label Hess cycle to show your working. Okay, so basically they're telling, okay, now the reaction is, okay, this they are trying to say this one is sucrose. Okay, so sucrose with water. okay, it's going to give you glucose and fructose. Yeah. So I know that, okay, so if I put it over here, sucrose, okay, plus water, they will give me, okay, glucose and fructose. Okay, this is going to be, I'm still planning how to draw the Hesse cycle. Yeah, but this is what they want. They want the enthalpy of reaction of this. Okay, but I know, okay, I know that glucose, okay, glucose can react, okay, can react with water. Sorry, I know that combustion, yeah, glucose, okay, can combust, okay, to give you carbon dioxide and water. Okay, they can combust to give you carbon dioxide and water. And I know that fructose also can combust to give you carbon dioxide and water. And I also know that sucrose also can combust to give you carbon dioxide and water. So roughly, you can have a relationship over here where you can have a common thing, which is carbon dioxide and water. This is the common thing. So here it's going to be delta combustion, okay, and so on. Okay, this is rough plan, yeah, the rough plan over here. So we can use this to calculate, okay? So you need to draw the label Hesse cycle for this. So using this, you need to plan, okay, how you want to actually draw the Hesse cycle over here, okay? Okay, let me check, okay, whether they have drawn, okay, here, okay, 3C3. They didn't show the diagram over here. Okay, they didn't show the diagram over here. But generally, you see here, okay, when sucrose, okay, when they combust, okay, to give you, okay, I can just write down over here, sucrose. Sucrose is going to be C12H22O11. Okay, so C12H22O11, okay, when I add with oxygen, they are going to give me carbon dioxide and water. Okay, I want to find out how many moles of carbon dioxide and water, yeah. So here is going to be, they are going to have 12, okay, 12, and then 22, okay, so it means 11. So oxygen 11, okay, plus 24, 11, so it's going to be 35. So out of 35, 11 is there. Okay, so if I minus, I need 24, so this one should be 12. Okay, so it means that I'm talking about 12 moles of carbon dioxide, okay, and then 11 moles of water, 11 moles of water. Okay, and if you want, you can write down, yeah, everything, but generally you don't need to worry. Okay, this is already good enough. Okay, it's already good enough. Okay, if you put like this and then you put like this, it's good enough already. Yeah, so here, how to actually calculate? Okay, quite simple. Okay, clockwise equals to anti-clockwise. Okay, you see the this one HR, okay, this HR, okay, plus, okay, the combustion of glucose, okay, combustion of glucose is going to be negative 2805, and then the combustion of fructose, okay, is going to be negative 2810, equals to, okay, clockwise equals to anti-clockwise, so this combustion, okay, of sucrose is going to be negative 5643. Can you help me to calculate what is going to be this?
Negative 28.
Yeah. So this is going to be the answer. Okay, it's kilojoule per mole. Okay, but doesn't matter. They always give that. Okay, so it's going to be negative 28. Okay, if you are not sure how to do this, yeah, again, please think about, okay, it's combustion. Okay, combustion means glucose is reacting, fructose is reacting, sucrose is reacting. So something reacting means it is the arrow will be facing out. Okay, it's reacting with oxygen, means sucrose plus oxygen. this one plus oxygen, okay, and so on. Okay, can even? Okay, let's move forward. Yeah. So here, okay, you have hexane. Okay, the moment you see hexane, this is already alkane. Okay, so C6H14. Okay, if you don't know it's alkane, also CnH2n plus 2. Okay, automatically double plus 2. Yeah, so it's going to be a general formula for alkane. Yeah, so it's a colorless liquid. Okay, 2 test tubes containing equal amounts of hexane. Okay, you have that, and then 1 cm cube of bromine. Okay, is added to both test tubes. Okay, one is kept in dark, another one is exposed in sunlight. This one is actually related to free radical substitution. Yeah. So here in the dark, okay, you see no change. Mixture remains orange. In sunlight, okay, the color of the mixture fades to pale yellow. It means there is a reaction. Okay. So when we say remain orange, all this here, basically is the color of Br2. Okay. Br2, the color is going to be orange. Okay, or reddish brown. Okay, but in this case they say orange. But the orange become pale yellow. It means the Br2 is reacting. Yeah, it's reacting. So the test tube in the dark is kept cool and not exposed to ultraviolet light. Okay, so explain the observation. Okay, for the test tube kept in the dark. So no reaction. Okay, why? Okay, no reaction because okay, hexane is saturated, okay, or contains carbon-carbon single bond, and no free radical substitution occurs if kept in the dark. Okay, this will be my answer. Okay, let's see what they are expecting. Okay, the answer that they are expecting is slightly different. Yeah, they are expecting slightly different. The answer is going to be, they say no reaction. Yes, I'll get the mark for no reaction. Okay, probably not, because not enough energy. Okay, means they want me to explain more. Yeah, just simply saying no free radical substitution is not enough. Okay, they want me to explore and say free radicals are not produced, or homolytic fission of bromine does not occur. Yeah, so it means this one maybe, okay, if it is the examiner, okay, they might give me full mark. Okay, but better, okay, if you follow the marking key, they say no reaction. Okay, no reaction because lack of energy. Okay, lack of energy to produce free radicals. Okay, free radical, okay, or to cause homolytic fission. So homolytic fission must be happening first. Okay, so this one not there. Okay, but my answer maybe not that strong. Okay, but it's still correct. Still correct. Yeah. So in sunlight, okay, bromine reacts, okay, with hexane by a mechanism which occurs via a series of steps. Basically, this is going to be free radical substitution. Yeah. State the name of mechanism of the reaction that occurs. Yeah, I already mentioned over there. Free radical substitution. Can I write substitution only? The answer is no. Yeah, you must mention free radical substitution. And then give an equation which shows a propagation. Okay, propagation, always remember, neutral with free radical. Okay, it will give you neutral plus free radical, it will give you another free radical. It means free radical will be still produced. Okay, that is propagation. Yeah. So in which the hexane produced this one. So let's actually try. Yeah, hexane is C6H14. Yeah. So if I put there C6H14. Okay. If I write down from the beginning, initiation. Okay, if you follow from the beginning, initiation, if let's say Br2, yeah, so Br2, so initiation Br2 with the presence of sunlight or UV light, they will have 2 free radical Br. Okay, so I write down like this. Okay, 2 Br free radical. Okay, but propagation, okay, they want the first step only, propagation. For propagation, okay, do remember it must be neutral with free radical. So what is neutral? Okay, you start with C6H, H what? H14. This is neutral. You start with free radical. Okay, and they will give you C6H, one of the H will go out with Br. Okay, so H13. So now one of the carbon now is going to become a free radical. Okay, you are going to have a free radical, and this is going to give you HBr. And okay, if you continue, so now this is a free radical C6H13. They must react with what? Must be neutral. Remember, neutral and free radical. So just now this is neutral, this is free radical. Now this is free radical, must be neutral, Br2. Okay, Br2. Now the Br will go inside, okay, and join, okay, the free radical will be removed. So you will get C6H13Br, okay, but now you have further another Br free radical. Okay, this is how it works. And it will continue. Okay, but to answer the question rather than wasting time, okay, give an equation for propagation step in which hexane produces this free radical. Producing that free radical is going to be the answer. So you just need to write, okay, C6, okay, H14 plus Br free radical to give me, okay, C6 H13 plus HBr. Okay, that's going to be the answer. Give an equation, okay, which shows a propagation step in this reaction that produces one bromohexane. Good thing I already wrote. Yeah. So one bromohexane, this one. Yeah. So just need to write, okay, free radical C6H13, okay, plus Br2. C6H13 Br plus Br free radical. Give an equation, termination step, okay, initiation, propagation, termination. What is termination? Termination is going to be free radical with free radical. They will form something neutral. It means they are stopping. Okay, but this one, they say producing one bromohexane. So it means something that producing C6H13Br. Okay, this one quite simple also. Just go and take C6H13 free radical, okay, and you join with another Br free radical. Okay, you will get that. Okay, so no need to think a lot. Okay, so this is going to be free radical, okay, it will give you termination step. So C6H13, can you understand this even? James, are you okay?
Yeah, okay, sir.
Okay, this is the equation. Yeah? Now, if you look at this, okay, A and B are different straight chain alkenes, okay, with a molecular formula of C6H12. So they already mentioned that they are unsaturated, okay, alkenes, okay, it contains double bond, yeah, and they mentioned it's a straight chain, yeah, so it means 6 carbon, okay, don't know where the double bond, yeah, but there will be double bond, okay, maybe one will be here, okay, we don't know which one, yeah, but there are 2, yeah, A and B, they are different straight chain, okay. A does not show stereoisomer. So let's actually see what are the different type, okay, of straight chain, okay, can be we can get. One is like this, another one if I have 6, okay, and then the double bond will come over here, okay. And one more is going to be, if I have 6, the double bond will come over here. Okay, so these are the only possibilities. Yeah, 3 types. Yeah, three types. So they say different straight chain. I don't know which one is A and B. Okay, but they say A does not show stereoisomerism. Okay, what is stereoisomerism? Okay, stereoisomerism means there are cis and trans. Okay, and also cis and trans, and also optical isomerism. They don't have. Yeah. So let's actually see whether this one, okay, can have cis and trans or not. Okay, you see here, this is H. Okay, so this one is different group. Okay, but you see this is H, this is H. Cannot have cis and trans. Okay, in order to have cis and trans, this one must be different group. Okay, cannot. Okay, so still valid. Okay, still valid, can be A. Okay, but if you look over here, this is H, this is going to be H, different group, different group, different group, different group. Cannot be this. Okay, because they can give you cis and trans. Okay, the same thing here. You see, this is hydrogen. This is going to be hydrogen. Okay, you see the carbon is attached to 2 different groups. Carbon attached to 2 different groups. They can have cis and trans, cannot. So this is going to be A. Okay, so A reacts. Okay, so now we know. Okay, this is going to be A. Okay, A reacts with potassium manganate to form hexane 1,2 diol. Okay, you see, when you react with potassium manganate, this one is cold, under cold condition. Yeah, so they will give you the OH here, OH here. Okay, then the remaining is going to be carbon. So you see here, okay, when I name this, okay, it's hexane, position number 1, position number 2 diol. Okay, so it's correct. Okay, so it means that if they ask you to draw the structural formula of A, be very careful with this, because even though they say draw, structural formula you don't draw. Yeah, so don't forget about this. Okay, this one, if you draw, okay, it's supposed to be displayed formula. Okay, so you don't draw like normal. Okay, when they say structural formula, this one, okay, is going to be, okay, let me go again. This one, okay, is going to be CH2. Okay, CH2, okay, CH2, then double bond over there. So I think better if I can show them the double bond. C double bond C, okay, H2, okay, and then there is H, so CH, CH2, H2, CH2, CH3. So this should be the answer. Don't go and draw, yeah? Okay, this is the answer that they expect from you. Okay, so please make sure you don't go and draw, okay, the displayed formula over there. Okay, we don't want that to be done. Correct identification. Okay, hold on, yeah, let me check. Right. Okay, so you can just write down like this. Okay, cannot draw the displayed formula. Yeah, state the condition needed, okay, for this reaction of A. Okay, so what is the condition? Okay, the reaction of to change to hexane 1,2 diol. Just now I mentioned cold condition. Okay, another condition is must be dilute. Yeah, and they didn't mention about acidified. Okay, it must be acidified also. So the conditions, okay, will be must be cold. Okay, dilute KMnO4. Okay, and acidified. Okay, maybe you can say dilute. Okay, dilute H2SO4. Okay, so if you look at the answer over there, cold and acidified and dilute. So don't forget, they want all, yeah. So it means that if you miss any of this, you will not get the mark. Okay, Ken? Even so, quite tricky, right? So you see, cold dilute, sometimes you will miss the acidify. Okay, it will not work if you don't acidify them. Okay, it must be all the three must be given. Okay, in order to get the full mark. Yeah. So don't worry. Okay, we will not go and finish everything. Maybe let me see. Maybe we can finish everything. Okay, are you okay to continue for another? I don't know how long it will take. Okay, James.
Yeah, okay, sir.
Yeah, let's get it done. Yeah. So B, okay, I do not know how long we took already. Okay, but now it's 5:45. I'm going very slow. Yeah, so I'm not looking at the time. Yeah. So maybe by 6:15 we should be ending already. Yeah. Now B reacts, okay, with hydrogen gas, okay, in the presence of platinum catalyst, okay, to produce hexane. Yeah. So we are looking at B. So B means one of it. Yeah. Just now remember, okay, when we have three examples. Okay. So this one is confirmed A. So now, okay, we are looking into B. I don't know which one is B. Okay, can be these two. So maybe I'll just select and bring over there. Okay, I'll copy. I'll put it here. Okay, now B reacts with the hydrogen gas in the presence of platinum catalyst to produce hexane. Okay, so they don't want you to draw anything. They just say, okay, B reacts. Okay, B. Let me see what is B. Yeah, it's still alkenes. Yeah. So B reacts with hydrogen gas in the presence of platinum catalyst, okay, to produce hexane. Okay. Name the type of reaction that is occurring. Okay. So Ewan, what is the type of reaction that is occurring? A carbon double bond carbon, okay, reacting with hydrogen. So they will give you carbon single bond, and then the hydrogen and hydrogen will come. Okay. What type of reaction is this for Ewan?
Substitution?
No. Definitely not substitution. It's being added, right? Okay, it's being added. So the answer is not substitution. Being added means you're breaking the double bond, you are adding the hydrogen. Yeah. So it's addition. Okay. So whenever you're talking about double bond being added something, so it's supposed to be electrophilic addition. Okay. So remember this. Okay. So the mechanism of the reaction, okay, is going to be the type of the reaction is going to be electrophilic addition. Okay, but this one also can be also known as hydrogenation. Okay, let me actually look at the marking key. Okay, the marking key is not specific to electrophilic addition. As long you mention is addition is correct. Okay, addition, or sometimes if you some students will say reduction is still correct. Okay, but I want you to write, okay, addition, or if you can write electrophilic, it's okay, even though they don't require it. Okay, it's very important that you know about that. Okay, so in terms of sigma and pi bond, describe any similarities and differences in the type of carbon-carbon bonds in B and the type of carbon-carbon bonds in hexane. So basically, they are talking about, okay, this one in B, there is carbon-carbon double bond. Okay, this one, no carbon-carbon double bond, all single bond. So it means that there is a difference over here. Okay, B has sigma and 1, okay, pi bond. Okay. Between carbon-carbon bond, whereas okay, in hexane there is no sigma bond. Okay, sigma bond is for the double bond. Okay, so just to check, okay, James, if you have like this, how many sigma and how many bond pi bond over there? Always remember this one thing. Yeah, sigma. Okay, sigma is going to be only one. Okay, because it's going to be carbon and carbon only. Yeah, so that is going to be your sigma. Okay, so if I have another hydrogen, then this is also sigma. If I have another hydrogen, that is going to be sigma. Always remember that. Okay, but the remaining ones, okay, will be what we call as pi bond. This is pi, this is pi. So in this case, there are two pi bond. Okay, so please remember this. Okay, sigma is only one. Okay, so you can actually say it as between one atom to another atom, there is only one sigma, something like that. Yeah. So that is going to be the explanation for that. Okay. Anyway, for D2, let me check the answer. There is only one sigma, and then B has sigma and one pi bond. Good enough. Okay. They will give you 2 marks for this. Yeah. Now, next question. Okay. I think this is the last question. Yeah. Last question. Okay. C, D, and E are isomer of each other. Okay, they are made by passing an alcohol vapor, okay, over an aluminium oxide catalyst. Yeah, so basically they have this alcohol vapor and aluminium oxide catalyst. Okay, if you remember this properly, yeah, this is what we call as dehydration reaction. Okay, so you pass alcohol, okay, with aluminium oxide, okay, they will dehydrate. It means the H and OH. Okay, so if I, let's say I have like this, H and OH, okay, dehydration means this one will go out, they will give you the carbon double bond. Yeah, this is going to be dehydration reaction. So name the type of the reaction occurring. Yeah, no need to think anything. This is going to be dehydration. Okay. Draw the displayed formula of the alcohol used in this reaction. This one is isomer. Okay, so draw the displayed formula of the alcohol used in this reaction. So doesn't matter. Okay, as long that you show them the same number of carbon. You see here, 1 carbon, 2 carbon, 3 carbon, 4 carbon, and they want display formula. Yeah, please remember, don't go and draw skeletal formula. Yeah, 4 carbon that has, okay, H and OH. So it means I'm going to draw 4 carbon. Okay, 1, 2, 3, 4. Okay, since if let's say I'm just based on C, yeah, so it's going to be carbon number 2 has H. This one has OH. So H. Okay, this is it. Done. This one you will get the full mark. Okay. So this one, the H and OH, they can be anywhere. Yeah. Depending, like if this is for C. Okay, but for D, let's say for example between this carbon number 2 and carbon number 3. Okay, same also carbon 2, carbon 3. Okay, this one 1 and 2. Okay, maybe this one between here and here. So okay, 1, 2, 3, 4. 1, 2, 3, 4. Okay, it doesn't matter. Yeah, so it's still the same. Okay, you will still get this one. Yeah, display formula of the alcohol. Now name the isomer. Now they are going to name the isomer. Okay, if I want to name the isomer over here, okay, you see here, okay, I think they are almost the same. You see, this is going to be position 2 to 3. Okay, this is going to be position 2 to 3 also. Okay, so if I name this, okay, it's going to be 1, 2, 3, 4. Okay, you want to name the C itself. Yeah, so this one 1, 2, 3, 4. So this one is going to be butene. Yeah, okay, position 1, position 2, position 3. So position number 2 in, butene. Okay, and this one also, okay, if you look over here, 4. Okay, so position 1, position 2. So it's butene also. Okay, so must be something different. Yeah, must be something different. Later we'll go into that. So 1, 2, 3, 4, but. Okay, but now this is position number 1. So but 1 in. Okay, so you need to differentiate the butene. Okay, this butene and this butene must be different. Yeah, so how different are they? Okay, you just need to look at this. Okay, this is CH3. This is CH3. They are opposite. Okay, so James, if they are opposite, are they cis or trans?
Trans.
Yeah, so this is trans. Okay, you can see this is CH3 side by side, cis. So when they ask you to name, okay, you just need to name accordingly: cis, but, to, in. trans boot 2 in. And the last one is boot 1 in. Okay, done. Okay, the next question. Okay, so F, okay, let's see what is F. Okay, this is something new then. Okay, F is an organic molecule, okay, that has this molecular formula. Okay, so when F is heated with NaOH, okay, then after that you follow with H2SO4, okay, the following products are made. Yeah, so the following products, okay, are made, okay, so which is going to be G and H, okay. Separate sample, okay, of G and H are added to this, and are added to this, okay. Just by looking at this equation, yeah, can you predict what is F for even? Are you able to predict what might be F just by looking at this? If no, also just tell me no.
Esterification.
Esterification or the other way around. You see, esterification must be one react with another one to give you ester, which is going to be alcohol reacting with carboxylic acid to give you ester. Yeah, but in this case, something is breaking down into two other products. So something, you are close to it. It's esterification, but the other way around. Remember just now I mentioned about something, esterification, when you break it into that, what is the process is called? Lysis. What lysis?
Hydrolysis.
Hydrolysis, okay, and this one is called sodium hydroxide, okay, followed by H2SO4. So basically, they are going to use hydrolysis also, yeah. So they are trying to use, okay, sodium hydroxide, okay, and then H2SO4, okay, to convert this ester, okay. So this one is ester actually. Okay, and how do I know? Because C3H6O2, yeah, that's 2O, yeah. If you have 2O, it can be carboxylic acid, okay, or ester, okay. So if it is carboxylic acid, okay, you react with NaOH, H2SO4 to give you two products. No, I don't think so. Okay, so the best answer will be ester. So G and H, okay, probably will be alcohol, okay, and carboxylic acid. Okay, so using this all these things, okay, we can actually identify, okay, what is G and H. Yeah, so you can see here, okay, when you use sodium carbonate, a colorless bubble of gas is produced. It means there is a reaction. Okay, so I just want to ask, okay, can alcohol react with sodium carbonate? Given?
I don't know, sir.
Okay, do remember this. Yeah, do remember this. Okay, alcohol. Okay, they can react with metal. Yeah, they can react with metal. Okay, to give you hydrogen gas. Yeah, but okay, they are not strong enough. Yeah, they are not, how to say, alcohol, okay, they do not react with sodium carbonate, okay, they don't react with sodium carbonate. If you look at carboxylic acid, yeah, it's acid, yeah, acid will react with sodium carbonate, okay, to give you salt, water, okay, and carbon dioxide. So this one, okay, is carboxylic acid. I'll just put over here. This is carboxylic acid, most likely, okay. And then sodium, okay, you see sodium, okay, it's going to be a colorless bubble of gas is produced. Remember just now I told you alcohol can also react with metal to give you carbon, to give you hydrogen gas. So you see, this one also give you colorless bubble. This one also produce colorless bubble. Okay, so it can be both. It can be carboxylic acid, okay, or it can be alcohol. So we cannot use sodium to determine which one. Yeah, so it can be both. Okay, colorless bubble can be sodium. Both, okay, both can react. So which is confirmed by this. Okay, we cannot use. But here, okay, another one is going to be, they say no visible reaction. Okay, no visible reaction. If you look at aqueous iodine, okay, this aqueous iodine is going to be the triiodomethane reaction. Yeah, triiodomethane reaction. This triiodomethane reaction can be used, okay, to for this, okay, if you have something like this, okay. This one we learn under carbonyl compound, okay. As long as you have CH3, it will give, yeah. But again, this one is carboxylic acid and alcohol. So when it comes to alcohol, okay, triiodomethane, it can be also used for alcohol, yeah. The alcohol must have, okay, the OH, they must have CH3, okay, must have hydrogen, then R. Then only they will give you, okay, a positive reaction. Okay, it means that this one, just now you see, we already identified this is carboxylic acid. Okay, when they say yellow precipitate, it means it must be either carbonic compound or this. Okay, yellow precipitate, we know it's not carbonic compound. We are not looking for carbonic compound also. So it must be alcohol. So the alcohol is a special type of alcohol. It will have this structure. Okay, it will have this structure. So here, complete the table to identify the functional group. Okay, the functional group, you see, F, okay, let's look at F, okay, F. Okay, F is going to be ester. Okay, ester. So the functional group is ester. Okay, because F, okay, we already identified, okay, it's going to be hydrolysis. So G, okay, we already found out is carboxylic acid. Okay, so carboxylic acid. H, alcohol. Okay, let me check the answer key also. Okay, ester, okay, carboxylic acid, alcohol. Different answers can be if you write the in terms of R, C, O, R is accepted. Okay, carboxylic acid, if you say carboxyl, also accepted. Okay, alcohol, if you say hydroxy, okay, or you write down ROH, all accepted. So anyway, okay, our answer, okay, for me, I think this is the answer that you should do, yeah, should get. Okay, but if you don't get, yeah, the other answers are acceptable as well. Now, name the yellow precipitate form. Yeah, I already mentioned to you, okay, what is that? Yeah, this one basically is CH3I, okay, CH3I, okay, this reaction, alkaline aqueous iodine, is what we call as triiodomethane reaction. So this is triiodomethane. Okay, so this one, sorry, this is wrong. Triiodomethane means CHI3. Okay, CHI3, triiodomethane. Okay, so draw the structure of G and H. Okay, so I know G is going to be carboxylic acid. Okay, carboxylic acid start from C3. Okay, of course C3 means must have carboxylic acid. Let's say G, I know this is carboxylic acid, and I know this is alcohol. So carboxylic acid, in order to have carboxylic acid, okay, most probably this one will be like this. Okay, something like that. Okay, let me check first. Okay, draw the structure of G and H, and let's see. Okay, if I have that, okay, this alcohol must be specific to this. Okay, so if it is this alcohol, okay, cannot have you see here, okay, for alcohol, this particular alcohol, okay, must have CH3. It means the alcohol must have 2 carbon. Okay, must have 2 carbon. So it means this one I'm wrong already. Okay, this one cannot be like this. Okay, H must have 2 carbon. Okay, must have the OH. Okay, still haven't decided what is this. Okay, but 2 carbon is already there. So G must have only 1 carbon because 3 carbon only, right? So must have 1 carbon. That 1 carbon must have carboxylic acid. So the only way to draw them is like this. Okay, this is the structure. So this one must have 2 carbon. Okay, so 2 carbon, okay, OH and CH3. Okay, so this one must have hydrogen. Okay, what else will be here? Okay, this one, okay, must be R group, but it's not C anymore. Okay, so it must be hydrogen. Okay, must be hydrogen. And even if you have any question, you can ask me. Yeah. So here, okay, when they ask you to draw the structure of G, okay, the structure they didn't specify, so any structure will do. Okay, a simple, just put double bond O. Okay, OH. H. Okay, the H over here is going to be carbon, CH3, OH must have H, and then this one I'm putting SH. Yeah. So this one, okay, if you look at it, okay, our answer is correct. Yeah, C2H5OH. Yeah. Okay, done. Okay. Okay, James.
Yes, sir.